In this video, I'll be talking about Arma Reforger ambient sound system, how it's implemented, and what it's capable of. Before we delve into implementation details, let's first outline a couple of key requirements for the system itself. Arma Reforger is an open-world game with a dynamic weather system and a day-night cycle. These were the primary criteria that guided our technical design. We had to ensure that the system will support all necessary states and seamless transitions between them. Additionally, we aimed to create a tool that would be easy to use for modders and would work out of the box if needed. This is why we couldn't rely on sound sources or zones manually placed into the maps, and instead had to create a fully procedural system. In the video, I will cover three major parts of ambient sounds in Reforger. The first being system for non-spatialized stereo loops used for wind and rain sounds. The second being system for playing sounds on vegetation entities. And the last being system for randomized spawning of sounds around player camera. Apart from these, there are a couple of other systems related to environmental sounds, but I won't be explaining those in the video. When talking about not spatialized ambience, I have to start with the system we call sound map. Simply put, sound map is a simplified bitmap representation of the terrain. Looking at the debug, you can more clearly see what I mean. The whole terrain is divided into meadow, city, forest and sea areas. Sound map is procedurally generated and its generation logic is fairly simple. Based on the number of trees or buildings or terrain height, values for each tile are calculated. Additionally, for each area type, we added blur filter so the user can control the steepness of the transitioning between areas. As you can see here, the transition between meadow and city is much longer compared to the transition between meadow and forest area. All this is on the C++ side, coded by our audio programmers. Using values from the sound map, we can play wind and rain loops for 4 different areas, and since the weather is dynamic, we can also use wind speed and rain intensity as another dimension to modulate the sound. Let's have a listen. When I'm talking about vegetation sounds, I mean looped, spatialized sounds, such as leaves rustling, rain falling on the foliage or insects, played on trees and bushes entities. Again, the system behind this is fairly simple. Originally, I wrote it in the script, but later on, a part of it was moved to C++. Essentially, we do a 25-meter query over entities around the camera. We find the closest 9 entities and spawn sound emitters on those. As camera moves, the process is repeated, omitting closest entities that already have the sound and stopping sounds on those that fall out of the pool of the closest ones. Sound map comes into play for these sounds as well. We use it for insects on bushes, where we play different loops for meadows, forest and city areas. Again, with the goal of making these areas as distinguishable from each other as possible. When selecting insect sounds, we also use time of the day to change the character of the area over time. When working on this system, I was having issues with spatial behavior and volume over distance attenuation setup. I feel like it's always a complicated question of how to implement sound for a large object that basically emits sound from its whole surface. After some experimentation, I implemented a feature I internally called cylinder-shaped sound source. Each tree has a defined cylinder-shaped volume around its crown, and the sound source moves within that volume to the closest point towards the camera. When the camera is inside of the volume, sound shares the position with the camera. In this case, I feel like this behavior works better than having only a static source in the middle of the foliage. Probably the most complex system for ambient sounds is the one that randomly spawns sounds around the camera. When I started with ambient sounds, I had a couple of ideas in my head. Main thing was I wanted to rely on positional sounds as much as I can, because I believe that this aspect is crucial for creating an immersive experience and the feeling of being present in the world. This system is used mostly for birds and insect sounds. For these, I did not want to just randomly spawn short sounds around the camera, but rather to create a sense of bird presence in the world by playing particular species sound for a couple of minutes from the same position. That's why I implemented a system that can create and play randomized sound event sequence with a fairly flexible configuration for every sound. The third aspect came up after, I think, the second iteration. It had partially practical and partially artistic reasons. The thing is that I recorded the majority of the bird sounds myself, and they were recorded at various distances from the birds. Meaning some of the recordings are very dry, but others have a lot of natural forest echo and reverberation. So from this point of view, it did not make much sense to manage the sounds recorded from very different perspectives together. To address this, I decided to divide them into 3 groups, into close, middle and far distance group, and manage every group separately. By doing so, it also gave me an additional tool to shape the soundscape. I could, for example, use only close birds if I wanted to make a more warm and positive sounding environment, or use only distant birds if I was going for something more mysterious. The last key idea was to have a simple parameter for controlling the density of the soundscape, so I can easily create very busy environments in the early mornings, very calm ones during nights, or lower the density in stronger wind, or even using zero density to don't spawn any sounds when it's raining. Since I already had 3 groups of birds, I decided to implement this density control on the group level. In the final setup, I added a group for insects and another group with miscellaneous sounds as well. In the end, controlling each of them independently proved to be a very useful tool. So, how the spawning logic works. In some sense, the logic is reversed compared to similar systems I encountered. In my case, first the position for the sound is generated, and then, based on underlying logic, the system looks for sound that could be played on that given position. In more detail, same as density, the whole spawning configuration and process is independent for each group. At the beginning, the density of already playing sounds is checked. If the density is not reached, then the position for sound is generated, either based on terrain material or sound map. Sound type is selected. Each sound type has a defined pool of sounds that the system can choose from. Before the final selection, a couple of additional checks are performed. There is a time of the day check and also a cooldown check, making sure that same sound is not repeated too often if it's not desired. If an available sound is found, then the system creates an event sequence and schedules the sequence for playback. Especially when using terrain material, it gives you wider possibilities for creating more unique sounding areas. In the case of Everon map, we can have different sounds for leafy and coniferous forests, 2 types of meadows, or frogs and waterbirds on pond areas.